In this chapter, we are diving into another essential concept of Java, that is variables. We'll break down what variables are, why we need them, and how they help us store and manage data in our Java programs. We'll also explore different types of Java variables, that is local, instance, and static, and how and when to use them. We'll also learn how to declare and initialize variables properly, some of the best practices while working with variables, and also about making the values of your variables unchangeable by using the final keyword. Let's get into it, shall we? Let's start with what exactly are variables in Java. You can consider them as little containers in Java code which are going to hold a value of certain type. Imagine them as labeled jars which let us know what data can be stored in it and what value is currently being stored in that container. It could be numbers, texts, or objects for that matter. For example, int age 5. Here age is the variable name, integer is the data type, and 25 is the value we have set for it. So this basically tells Java to create a small container with the name age in it, and that age container is only going to store the value of integer, and currently we have stored 25 as value for that container. But not all variables are same. Java provides us with 3 different types of variables to work with based on the use case and scenario. The first one is the local variable. These live inside a method or a specific block of code and are accessible only to that specific extent. They only exist while that method runs or that specific block of code is being executed. So here in this example, greet is the method. We have created a variable of string type with the name message in it, and we have assigned it a value of hello. So you can use this message variable inside this greet method only. If you try using this variable outside greet method, it is going to throw you an error. So once this greet method execution is complete, the variable disappears. Second is the instance variable. These are object level variables. These are declared inside a class but outside any method. Each object of that particular class is going to get its own copy of this variable, and this is perfect for storing object level data. Like for example, in the case of class car, it could have a variable called string color and int speed. So all of the objects created with this class are going to have their own set of these 2 variables, and they can have different values. Third is the static variable. These are declared using the static keyword, and these are shared by all the objects. That is, static variable belongs to the class itself and not a particular object. So all the objects you create for that particular class, they are going to share the value of the static variable. So for example, in the car class, you can add a static variable car count. So this can be used to store the number of total cars. This is the total number of objects which are created using the car class. Let's quickly recap. Local variables are temporary, short-lived, and they exist only for a particular method or a block of code. Then comes the instance variable. These belong to the object and they store the object's individual state. Then comes the static variable. These variables belong to the class itself and they are shared across all of the objects created for that particular class. Now let's discuss variable declaration and initialization. Before you start using variables in Java, you first need to do 2 things. One is declare a variable and then initialize the variable with a value. You can do these 2 things in 2 different steps or in a single step as well. Let's go through it. So variable declaration is like reserving a space for that particular value. So declaration is like saying, hey Java, I need to store a number or a text. So give me a variable for it, and you just write out its name. So for example, int age and string name. Here you have created variables with age and name. You have also defined its data types so that based on the data type, Java is going to allocate that specific amount of memory while execution of the program. But at this point, Java just knows the data type of the variable. It is not storing the value itself. So that's the thing which happens in the second step, that is variable initialization, giving it a value. Now Java has created containers for age and name. Now you can add values to it. So age is equal to 25, name is equal to lazy coffee. So you can assign values to these variables by using the assignment operator, that is the equal to operator, and this is how you can do it in 2 steps. You can also do it all in single step, in a single line, like double balance is equal to 1000.50. This line also tells Java that I need a decimal box which is going to hold a value of double, that is decimal, and you need to store value 1050 inside it. So key takeaways from this is the variable declaration itself reserves space in memory for that particular data type. Initialization assigns a value to that variable, and you can do them separately or together based on the use case. Sometimes you might need to do it in 2 steps. Let's say you're creating a variable in the class and you're assigning value to that variable in a method. So that's when you're going to need 2 steps. If that's not the necessity, you can just create a variable and assign it a value in a single step as well. Let's quickly go through some of the naming conventions for variables, because this is very important. Because variable names are not just for the compiler, they are for us as programmers. Good names make the code much easier to read, debug, and understand. First is use meaningful and descriptive names for your variable. A good name always tells what that variable is supposed to do, or what kind of value that variable is supposed to hold. For example, you can create a variable int account balance or customer name rather than int a or int x. Second is the follow camel case naming convention. That is, the first word in your variable starts with a lowercase and the subsequent words in that variable name are going to start with the uppercase. For example, here interest rate and string customer address. Avoid using uppercase while starting the variable name. That is not the standard naming convention. Avoid using special characters in your variable names, and avoid starting your variable names with a number. That is not a standard convention. Do not include spaces in your variable name. That is going to throw you an error. Do not use Java keywords as variable names, as we have discussed in the earlier lecture. Java keywords are reserved words which offer specific functionality, so don't use them as a variable name. Keep the variable names short and clear. Avoid using single letter names for variables unless you're using them in an if-else condition or a for loop. To summarize the naming conventions, always use meaningful and descriptive names. Use camel case naming convention. Don't use special characters, or don't start your variable names with numbers. Always start with lowercase. Avoid reserved Java keywords, and keep the variable names short and clear. These practices are going to help you set a professional tone for how your Java code looks, and it also makes it easier for us as programmers to understand what is the purpose of that variable. Let's quickly talk about final variables. This is a Java feature which is going to help you protect the values of a variable. Let's say you don't want a value of variable to change. You can use a final variable for it. Think of final variable as a sealed box. So once you put a value inside it, that box is sealed and you cannot change that value. Trying to change the value of a final variable is going to give you a compile time error. Where do we use final variables? They can be used where the values need to be constant, something like interest rates or tax percentages or account numbers, API keys, or configuration flags. You can set these constant values as final variables so that their values cannot be changed during the course of your program execution. Now let's quickly go through a code example to discuss variables. So here we have created a new class. I'm going to add a main method for it, and here we have our code. Now the first thing we are going to try is the declaration of a variable. You are going to declare a variable by just writing a simple statement, int count I. In this step we have just declared a variable. It still doesn't have any value. You can assign it a value like count I is equal to 5. You can try printing out the value of count I, and you save the program and run. So here, after initialization, the value is 5. If we try printing the value of count I before the value is initialized, it's going to give us an error. It says that the local variable may not have been initialized. So it's only after it's initialized with the value 5, it's going to allow us to print the value of count I. Similarly, we can also declare an initialize value of a variable in a single step with something like this. We have created the variable of integer data type, and here we have straight away assigned it a value of 15. So that is how you can do it in a single step, and we can write a simple print statement to print out the value, and let's save the program and run. So here we have 15. Here you can also reassign the value for a variable, let's say here like this. So count j here is 15 and we are going to reassign it a value of count j plus 10. So it's 15 plus 10, that is going to be 25. If we try printing out the value of count j again and save, so it's going to give us 25. So that is how you're going to reassign the values for variables, and you're going to do this quite often in your Java code because the value of variables can change over time. Now let's quickly declare a constant. That is a value which does not need to change. You can do that by final keyword. So final, integer and max count. Carefully observe, I've named this variable in all caps. So that is the standard naming conventions while you're naming a final variable. So max count is 100. So now if I try printing out this variable, it's going to give me 100, and that is as expected. Let's say if I try changing the value of this max count variable, let's say I assign it as 50, it's giving me an error. It says that the final local variable cannot be assigned. Java enforces that condition on final variables, that is its value cannot be changed. Let me comment it out. Now let's quickly create some variables to understand the naming conventions. So if you want to create a variable for number of students, you can create something like number of students. So here you observe n is smaller case, O and S are uppercase. So this is following the camel case naming convention. You can print out the value of this variable here like this. Let's save and run. So it's 30. This variable name is also pretty self-explanatory and descriptive. So let's say another programmer reads this variable. That programmer should be able to understand the purpose of this. So that's the idea, keeping your variable names short, descriptive and informative, and also following the naming convention of camel case. Another example would be like, let's say we want to create a variable for total amount. You can create a variable like this, int total amount. You can also create a variable like this, but this is not a standard naming convention. It's a best practice to always follow the camel case naming convention. And another best practice is always try initializing your variable as soon as you can. Let's say I want to create a variable for sum. I'm going to create an integer. Sum is equal to 0. Sum is equal to count I plus count j, and a simple print statement to print out its value, and save the program and run. Value of sum is 30. That is, it's adding count I plus count j. So this is working as expected, and that is pretty much about the code example for the variables. Let's quickly go through some of the best practices and tips while working with variables. We have discussed a couple already. Use meaningful and descriptive names for your variables. That's how it's going to make it easy to understand the purpose of that variable. Choose the right data type for your variable. This is going to help keeping your code accurate and memory efficient. Follow the camel case naming convention. That is going to make your variables much more readable. And always, as soon as you can, try initializing the variables before using them. As much as it's possible, keep the scope of your variable short and limited to that particular code block. Shorter variable scopes reduce confusion and bugs. Use final keyword for the constant values, that is the values you don't want to change during the program execution, even by accident. Avoid magic numbers, that is avoid hard coding any value in your code. Instead, convert them into a variable so that they can be reassigned as needed, and be consistent with your naming style. Stick to one naming pattern, so that is going to give you a certain sense of uniformity in your code, and it also makes it look much more professional. Remove unused variables, that is if your code has certain variables which you are not using in any way, just get rid of them. You can group related variables together, that is, let's say you have variables created for students, so you can group them together. That is going to help you organize your code. And use comments to explain complex variables. So whenever you have created certain variables which are too complex to understand by its naming, or the purpose is too complicated, you can add a simple comment letting know what is the purpose of that variable. And that wraps up this chapter. We took a step forward in understanding the concept of variables. We explored, we understood what variables are, how to declare them, how to initialize them, how to use them. We just had an overlook about the different types of variables like local, instance, and static. We will be exploring these variables as we proceed with other concepts like classes and methods. We went through some of the standard naming conventions which are going to help you keep your code professional and standard. We also had a look at the final keyword to create final variables. Understanding how to work with variables is going to give you the ability to store, manage, and manipulate data efficiently in your Java code. In the next chapter, we are going to explore the concept of operators in Java. They are going to help you perform operations on these variables which you have created in this chapter. We are going to have a look at different types of operators like arithmetic, logical, assignment, comparison. We are going to see how Java helps us create expressions using these operators and variables. And that's about this chapter. I'm Venkatesh Mudaliar. Till I see you again in the next one. Cheers.